forget about interventions if you simply look at controls. Control-to-control differences are as large as 15%.
So better than drug.
15.
Yeah, better than drug itself.
So when I ask these people, how do you explain 15% difference? They honestly tell me, we don't know.
Yeah, not everything as it seems when it comes to aging biology and the longevity field in general. And that's mostly because what you hear comes from, how shall I put it mildly, sales. So today I'm going to visit the real trenches, and we are going to give it to you as it is. We are mostly going to discuss the mess we have in animal data and international effort aimed to improve that, but also what you personally can do to help the situation. So let's get educated together. Again, it's also to educate me. I want to translate it to my subscribers, what we're doing here, why is it valuable for longevity field, what is the biggest current problem with mice models, how we can make it better.
So it is not so much a problem with a mouse model per se. I would say it's a problem with the general field. Whenever you have an experiment of a certain kind, an experiment where you measure long-term effects of intervention, be it a change in diet or a drug, and then you just want to know what does it do to a lifespan. You, of course, always want to know what does it do to a health span. You don't want an animal to spend the rest of their life in lethargic sleep or something. But it is difficult to judge health effects sometimes. Some tissue looks better than others. Uniformly sampling slices of kidney is difficult. Sometimes an animal feels great and is very active, but actually overexerting itself, and so on and so forth. Lifespan is a number, and numbers are very convenient objects to work with statistically. Of course, as my friend and colleague famously says, when there is a strong effect in biology, you don't need statistics. If you bring me a mouse which lives 5 years, and the normal mouse lifespan is 3. About 3 max, median lifespan is more like 2, you don't need statistics. One mouse does it. But normally we're looking at effects which are about 10, 15, at best, 20%. And you need statistics. So you want to reliably tell the difference, you want hundreds of animals. So now this is a long process, multi-year long experiment. Each lab does it somewhat differently. And you have this literature of tens of thousands of papers with the results of lifespan interventions. We would like to analyze all of this data together. I think the common misconception when thinking about lifespan experiments is that we are looking for an elixir. But it's quite foolish to expect that we find the intervention which radically extends the lifespan.
So it's mostly going to be a combination.
Yes, combination is a better way to think about it, but it is not even about combinations. This is, I would say, the first phase of lifespan studies is to have reliable data on hundreds of interventions, some of which are beneficial and some are mildly toxic. Because together all this data would tell us which pathways are important, what is causal about these interventions with respect to lifespan. So we would like to bring all of this data together to common denominator. Yet, when you read all these papers, every lab, even if they use the same animal, same species, even if they use the same strain, they do things somewhat differently. There are so many different parameters with diets, light cycle, how many animals cage together, how physically active can the animal be in this current environment, what's proximity between male and female cage, and so on and so forth. Everything is somewhat different, and all of this might potentially have an effect. There is unpublished data from the best program known to me called Intervention Testing Program.
Yeah, Miller's lab, right?
I'm sorry?
Miller's lab.
Exactly. So this is an excellent program by Rich Miller, which actually happens in 3 different labs. Right? So mice of same strain are put on the same intervention in 3 completely different locations. So if you forget about interventions, if you simply look at controls, control-to-control differences are as large as 15%.
So better than drug.
15.
Yeah, better than drug itself.
So when I ask these people, how do you explain 15% difference, they honestly tell me, we don't know. It could be many things. We could speculate ad nauseum, but we do not know. So when you have control-to-control difference of 15%, getting excited about some intervention which extends lifespan by 15% is difficult. So I came up some time ago with a project that I call ALEC, Animal Life Expectancy in Controls, where I say, I don't care about interventions. When yet another new sensationalist paper comes out telling us that oxygen or resveratrol or God knows what else extends your life by 15%, the first thing I want to do is say, which animal, which species, which strain, how long did this strain live across other laboratories? Whatever experiment they did. And then I could put the controls in context. If their control obviously was just very uncomfortable, was poisoned early, then I don't care about this life extension, because it would be similar to all of the healthy adult humans suddenly starting to take some chemotherapy, because we know that for cancer patients it's definitely beneficial. It has been shown, but cancer patients don't make very good control for extending healthy lifespan. That's the logic. So when I started the project of collecting the data across strains in controls, I met Eduard, who suggested that we kind of broaden this project, that in fact there are many useful experiments with negative results, where people publish papers saying, we tried this and that, it didn't work, but it's a large cohort. And so that's how COLLIDA was born. Let's find all the papers of life extensions, for starters, only in mice, and bring all this data together to analyze jointly and to contrast human trials against mouse trials. Today, there were many attempts to build this, but none successful. Many servers with data have been published. All of the servers are dead, so you cannot get such data anywhere. And we wanted to crowdsource the effort of looking at papers mentioning mice and lifespan and extracting very basic information of which strain was used, which gender, what conditions, what is an actual effect.
So right now there is no data, like if you take certain mice genotype, we don't know how long they live on average? Why is it even a problem? And don't you know that this black mice of that...
I was shocked to discover that it is a problem. Many years ago when I first said, well, there's this interesting species. How long do they normally live?
Yeah.
There are databases telling you that cats live up to 43 years and dogs normally live 15, but it is largely based on anecdotal data from zoo. We have excellent data for people, for obvious reasons, but for many species we don't know. For many strains of the animals we do not know the whole distribution, so to speak. We have some anecdotal evidence about maximal lifespan, but not very good data about median lifespan and the distribution.
So actually one of the problems is to figure out how long this typical lab mice live to begin with. Because it looks like in every control it can go up and down, and it's like controlling control.
So first of all, where do the strains come from? Many strains were developed in Jackson Laboratory. So if you want to start working with a certain strain, you go to the Jackson Laboratory. They have pages for each strain, which would give you, among other statistics, expected lifespan. It's pretty good, but not necessarily great for lifespan experiments.
Why?
Because many people who work with mice would tell you that we have no idea if normal conditions are optimal for these mice. There are animal experiment committees in every university which have regulations, but those regulations usually overstress hygiene and understress things like exercise. And diet is usually very simple and the same. I don't know how long I would live if I ate the same exact perfect sandwich every day. even if it's perfectly formulated, and nobody understands what's the perfect calorie at this level of exercise, at this temperature. Temperature is always in nature varied. In cages, obviously, in the lab, it is usually kept the same, which is also very unusual for an organism which evolved in changing temperatures, and so on and so forth. So it's not clear what do we compare to when we compare to controls.
Okay, so again, just to conclude all this, what is the biggest problem we are trying to solve? All the data disparity between the labs, trying to put it into one common sort of background, one common database, where you can say that, okay, this experiment controls lived so under 15% less than usual, we can completely disregard what they found.
What we are trying to solve is to create an effort where you can get good data at your fingertips, where you could easily go and say, let me see every paper that has been published using males of this strain.
Okay.
What's the distribution of controls across studies, and what were the most promising interventions? Today, there is no database like that.
Okay. So who is going to use this database mostly, you think? Do they know? How do we reach to people who are going to use the database? How do we get feedback from them? Who are those people to begin with?
I cannot predict exactly who are going to be the biggest users of the database. Again, when this project originated, I talked to enthusiasts who are interested in making a decision for themselves. You know, there is all this news and literature about resveratrol or rapamycin or metformin being beneficial. Then, of course, people would say, well, should I be taking metformin? And no doctor today would tell you, here, take this drug, it will extend your lifespan.
Yeah,
it's just, they don't know. Even if they knew, even if they take this drug themselves, they would not be allowed to recommend. So yet people are impatient and want to make this decision. Should they be making this decision? Probably not, but I'm not going to be the one to stop them.
Yeah.
Right. So how do you judge? You would like to know what did it do
to animals,
to animals and what did it do to people? Because if you want to use off-the-label drug, which is prescription drug like metformin, there is ample data on people who take these drugs. It is very hard to analyze this data properly match it with controls and so on and so forth, but you want all of this data. So yes, going and asking what does metformin do when it is taken chronically during lifespan of fish and flies and mice is a nice data point to have if this data is
available. Yeah, because I was kind of thinking from other industries, usually you try to address a need when some people, voicing opinion, oh, we would like to have this product, it doesn't exist. So my question was like, who are we trying to, for whom?
I only gave you half of the answer, right? The second half is where it gets interesting. There are enthusiasts who are impatient to start taking drugs. There are also enthusiasts who are impatient to try drugs on animals at home, in their garage, in their basements. They are curious to try drugs on fish and flies and worms and yes, mice. It is quite difficult to do, not something I would recommend you jump, but you could set up an experiment where you keep mice in your basement in cages properly and you try to see whether this or that drug affects their health, activity, and lifespan. So if you are such enthusiast with means, which drug do you try? So there is this idea that, well, there are not many people like that, but across the globe, you probably can find thousands. So now, if we coordinate and we say, you try this, I try that, we will collect new data going forward. But how do we select drugs to try?
Yeah, you need some list.
Right, so you need a list of good candidates, which is based on the current state of the art, unfortunately unavailable today.
So in a way, it's what Miller's lab does, right? They also have a list of suggested drugs to try, and they select whatever funds they have test and do it?
Sort of. They decide themselves what to try,
Yeah,
but
what's more-
it is a very slow and not a scalable process.
Yeah,
right?
because it's like takes 3 years to figure out.
Yes.
If it's going to
So
do anything or not.
ITP, I think, tried around 50 drugs in 15 years. I might be off by a dozen.
Yeah.
Now, most of the time, they just measure lifespan. There are no other tests. Then they freeze tissues for follow-up, but that's where it ends. So this is expensive and it's very difficult to scale up. Now there is a process of writing a proposal. You and I can decide that we want to test green tea because our grandma thought it's
Yeah,
great.
it's useful, yep.
We write a proposal to ITP, Intervention Testing Program. They decide, okay, that looks interesting, we will test it. So you and I get nothing other than our proposed intervention being tested by competent people. That's how it works. It's great. It's the best program today,
Yeah,
but
just need more of them.
it's quite slow. Right. And so I think that we are entering an era of democratization of science. Maybe not mice, but other organisms could be used at home. And as you know, I am enthusiastic about introducing new organism for testing.
Yeah, Daphnias.
Tiny
we'll talk about them
freshwater
separately.
crustacean.
Yeah.
Daphnias.
So, are there any milestones to this project? Where we are right now? What is next steps?
The milestone is that the first, or rather two first version of the tool as a web server have been developed. So now you can go and contribute 20 minutes per
Of the
paper
time,
approximately when you are on the train, on the bus, from your smartphone, from your laptop. The tool is there. It's released, could be used today.
So, what kind of education? You just need to be able to understand a study, figure out the graphs. What are prerequisites if somebody wants to?
You do not need
jump
to
on
be
it?
a trained biologist. I think if you care about lifespan and lifespan studies as an amateur, you are educated enough because you can go, you can read this paper, you find lifespan data. You do not need to go into technical details of these interventions. There are just a few basic questions like how many animals were there in control groups? Easy to find. What was the median lifespan of control versus intervention? Which strain was used? So that's something which
Pretty simple. So can any new language models be used to analyze that?
That's the first thing that came up when we started publicizing the effort. Several people said, why do you want to use humans when there's ChatGPT and large language models? We immediately tried and discovered what other people discovered, the drawbacks of large language models in context of other tasks. You instantly get very convincing looking
Bullshit.
answer.
Yeah, so there is convincing bullshit.
You never can attribute confidence to this result. So essentially, you can try to put this through, many things will come through, some will get stuck, but then you need human to validate the output of
Results
ChatGPT.
anyway.
That might be a faster way to do it actually, but it is not clear today exactly how to apply that.
So in a way, you need an in-house specialist who could optimize this language model to this particular task, relearn and make it better until it's 99% accurate or something.
Exactly, and I'm sure it will get there eventually, but I do not think we're there yet.
Anything else? Where you would like to be in a year from today? Is there any, how many people need to put their time? How many studies? What's the volume of studies we're talking about?
It's a large project. There are tens of thousands of papers, but I'm pretty sure there are hundreds of thousands of people who would be able and willing to do this if they knew of such opportunity. So I think it's largely a question of publicity.
Little social engineering.
Exactly.
So to our viewers, if you share this video with people who might participate, you will contribute in that way too, not just by analyzing the studies, but sharing with people who care. And hopefully if we find enough people, in a year we'll have great database. Some actual scientists can use.
Just to make
for
something
enthusiasts.
clear, the data resulting from this project will be most definitely freely available to every participant. If you contributed, you can get the data. That's our policy today as a little extra stimulus for people to participate. At the later phases of the project, we will freely distribute the data, no strings attached.
So to summarize, your help is needed and can make a real difference. If you have some spare time, the link to COLLIDA project is below. Go and review an article or two. If you don't have time now, just like and share this video, comment below, so it has a chance to reach more people. And if you are the kind of person who likes to experiment, we have a new longevity drug discovery platform, so simple, anyone can try it at home. Check this video to find out more. And remember, living is smart, aging is bad, so I'll see you there.